Hello, algebra students. Mr. Lawrence here, and this is a review for the test that we're going to have later in this week, probably on Thursday. And I'm just going to tell you right off the bat that this might be a 2-video review, because if it goes too long, I'm going to break it up so that you can watch the first part and then watch the second part. I'll probably post them at the same time, but that way you don't have to watch them all at once, since you do have a little bit of time. Now remember, this is only a review. I'm only going over certain things. So you need to be doing the problems in class, studying at home, study hall, whatever the case may be, coming to see me so that you can be successful. Many of you have very, very good grades right now. It would be a shame for you to do something silly and cause you to lose it. It would be even worse for you to know you're going to do that and still do it. You know what it takes to be successful. Now set your eyes on that goal and do what you need to do to be successful. Okay, let's get on with it. First we did multiplication and division of monomials. And the first one here, we have 3x times x. Now, we know there's going to be a 3 in the answer because there's a 1 there, right? Many of you are thinking that that's going to be just 3x, but remember, x times x is the same as x squared. Okay, now, on the second one, we're going to multiply our coefficients. We've got a lot going on here, so I like to somehow draw attention to what I'm doing. So, I've got an 8, which is a coefficient, and a 2, which is a coefficient. And then I have an x to the 4th, which is going to be multiplied by an x. And then finally we have a y squared, which is going to be multiplied by a y to the 7th. It's real simple. It's as simple as the previous problem, just 4 simple steps instead of 2. So first of all, if I multiply the yellows together, 8 times 2 is 16. X to the 4th times x, that's going to be an x to the 5th, right? You could put the little 1 there if you want, or you could think about it like this. That's x to the 4th times an x. Oh, there must be 5 x's being multiplied. Okay, y squared, y to the 7th. Again, you could think about it. Y times y, and then y to the 7th, like that. And so you're going to get a y to the 9th. Okay, division is very similar, except instead of the exponents being added, they're going to subtract. So I'm going to divide, match up my coefficients, okay, my x's and my z's, right? And so when I do this, 24 divided by 6 is 4. X to the 8th divided by x to the 5th is x cubed. And z to the 10th divided by z to the 9th is z. If I went too fast, well, here's the x to the 8th divided by x to the 5th. And then remember, these x's cancel. And look, there's x times x times x, which is x to the 3rd. I'm not going to do it for the z's. I'll leave that for you. All right, this one here, 54 81st. Well, I'm going to simplify. And I know 9 goes into both. 9 goes into there 6 times, and it goes into there 9 times. Well, 6/9 can simplify further. Dividing by 3, I can get 2/3. That's dividing both the numerator and denominator by 3 the second time. Now, by the way, since I divided by 9 and then I divided by 3, I could have divided by 27 in one fell swoop. Okay, but I didn't recognize that, so I did it in pieces. Okay, now I've got x to the 4th over x to the 3rd. Well, isn't that going to leave a plain old x? And won't he be in the numerator? Because there's more x's in the numerator than there are in the denominator. By that logic, y cubed over y to the 6 is going to end up with a y cubed. but it'll be in the denominator because there's more down there. So we're going to get a y cubed in our denominator. And then our z to the 6th are going to cancel out. All right, so there is your simplified answer. Let's come on down here. Raising a power to a power. Now, we're going to do 4 cubed. We're going to do x cubed to the third power. We're going to do y squared to the third power. And we're going to do z to the third power. Okay, and I guess I should have put parentheses around there to be consistent. Well, 4 cubed, that's easy, 64. Now this part here, x cubed cubed, doesn't that mean that there's an x cubed times an x cubed times an x cubed? Sure does. And wouldn't that mean that there's 9 x's being multiplied? Right? The y squared to the third power is going to be y squared times y squared times y squared. Well, it's going to be y to the 6th. I know some of you know the shortcut is just to multiply. That's fine as long as you're using it right. If you misuse a shortcut, it's the worst thing you can do. It deprives you of the chance of getting it right. But if you understand the shortcut and can do it, you go ahead and use it. All right, negative 2 to the 5th. So again, this is like negative 2 raised to the 5th, x raised to the 5th, y to the 5th, raised to the 5th, and z to the 10th, raised to the 5th. Well, 5 negative 2's, 5 2's will get me 32. Since there's 5 negatives, it's going to be a negative answer. X to the power of the 5th will be x to the 5th. Y to the 5th, there will be 5 y to the 5ths. This 5 tells me there's going to be 5 of these guys. So that's going to be y to the 25th. And then there's going to be 5 z to the 10ths. And that'll be z to the 50th. And there we go. Powers to a powers are quite simple. All right, 0 and negative exponents. Wow. Any non-zero number raised to the 0 power is 1. Remember? Okay, a negative exponent means to use the reciprocal. 6 squared would be 36. 6 to the negative second is just like 1 over 6 squared, or better yet, 1 over 36. Okay. X to the 5th times y to the negative second power. There's like an extra little mark in there. There we go. All right. Well, this tells me to use the reciprocal, not for the x term. His exponent is positive. This negative exponent says he needs to go downstairs. So if I build a set of stairs, I can leave the x to the 5th in the numerator and the y to the 2nd in the denominator. Remember, a negative exponent means use the reciprocal. What happens is the variable or the constant changes from the numerator to denominator or from denominator to numerator, and then the sign changes as it moves down there. So when I do a problem like this one, I like to get rid of this negative exponent first. So the first thing I'm going to do is I'm going to use the reciprocal. Right, 40x cubed y to the 5th z to the negative 6th. I'm going to put that over 36 x to the 5th y squared z to the negative 2nd. Now the 2's still there. It's just not negative anymore because I used the reciprocal. Now I'm going to simplify inside as much as possible. And noting these z's, there's a negative 6 there, so he's going to go to the denominator. There's a negative 2 there. He's going up to the numerator. So let's go ahead and simplify. And 40 over 36, I'm going to divide both by 9, and I'm going to get, by 4, and I'm going to get 10 over 9. X cubed over x to the 5th. Well, it's going to be x to the 2nd, and it'll be in the denominator. Y to the 5th over y squared, it's going to be a y cubed. It's going to be in the numerator. Now my z's are going to look like this. z squared over z to the 6th. And the whole thing is being squared still. I haven't done that. I actually have one more simplification step. The z's moved, but they didn't simplify. So I'm going to have 10y cubed and a 9x squared. Now I'm going to do my z's. A z squared over z to the 6th, well, that'd be like this. Just like that. Those are going to cancel. So I'm going to get a z to the 4th in the denominator. Now I'm ready to apply that exponent. And we're going to get 100. How to get 100? I squared 10. Y to the 3rd squared will be a y to the 6th. In the denominator, I'll get an 81, an x to the 4th, and a z to the 8th. And it's actually a pretty simple problem. Lots of little baby steps, but nothing difficult. Okay, we're going to do some scientific notation here, and then I'm going to pause the video and we'll make a second video. So, first of all, we're going to go convert to and from scientific notation. So we're in standard form. We've got this 6,230,000,000 number. And remember that to be in scientific notation, I need a non-zero number than the decimal point. I'm always going to end up being between 1.0 and it could be less than or equal to that. And then my number is x, and it'll always be less than 10.0. Okay? So what that means is, you could have like 9.99, but you can't have 12 point something. Okay? So I need my decimal point to be here, right? And we're algebra students, so we're not going to say, oh, we just moved the decimal point. I mean, in simplicity, that's what happens, but we're going to divide by powers of 10. And so let's see how many powers of 10 we divide by. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our new number is going to be a 6.23. Now, I said to divide by a power of 10. The problem in scientific notation always uses times 10. So when I'm dividing to get the number smaller, I use a negative exponent because doesn't that send it to the reciprocal? Send it to the denominator? So I'm going to do times 10 to the negative 9. What I'm telling you, mathematically speaking, this problem is the same as this problem. Where I just took the negative exponent right here and moved him to the denominator so you could have a positive exponent. You'll never give this as an answer to a scientific notation question, okay? Scientific notation is always done in multiplication. But mathematically speaking, they are the same value. Okay, well, let's take a look at this one here, the 4.23 times 10 to the negative 4th. I know that this negative exponent means it's like division. So this number here, this 4 2300ths, is being divided by a big power of 10. I mean, 10 to the 4th is 10,000. So if this is being divided by 10,000, it's going to get much smaller, isn't it? And what ends up happening, I have my 4, my 2, my 3, and the decimal point ends up moving 3 places to the left, okay? You see it was here, and it went 1, 2, 3, 4. I'm sorry, it moves 4 places to the left, part of my misnomer there. But there's your standard notation. All right, let's try that again. There we go. Okay, so when you have the negative exponent, it's like division. It is division. So your decimal gets really small. It's still positive, but it gets tiny. Okay, on the other hand, when we have this positive exponent, we're multiplying by 10 to the 5th, which is going to be 100,000. Okay, so this guy's going to be bigger. So let's see, that's 1, 2, 3, 4, 5. And notice the number of zeros does not have to match the exponent. Some of you think it does. That is incorrect. Somewhere at an early age, somebody lets you get away with thinking, oh, you just add zeros. Well, not necessarily. Not when you're dealing with a decimal. So make sure you're multiplying by powers of 10. You understand what's going on. If not, please come in and see me. Okay, one more and then we're going to wrap this video. I've got this tiny number here. I want it to be 4.5 something, right? I want the decimal point to be here. Well, I'm going to have to multiply by powers of 10. How many powers of 10 am I going to multiply by? 1, 2, 3, 4. So I am going to multiply by 10 to the positive fourth. And there you go. So our 4 answers, 2 in standard, 2 in scientific notation. All right, like I said, we still have some material to cover. We have adding and subtracting, multiplying, dividing scientific notation, graphing exponential functions, and then exponential growth and decay. And also half-life. So I'm going to pause this video here, and you can look for part 2 as soon as you're done watching this. Mr. Lawrence signing off. Good night, everybody.